So right now we're going to talk about the product and quotient rule for radicals. So what the rules are is that if I have, for right now I'm just going to put square root of A times square root of B. This equals the square root of A times B. And it kind of goes back and forth. It's like if we have two of the same type of radical multiplied, we can put A times B together in one radical, or we'll go the other way, and if it's things multiplied together inside the radical, we can pull it apart to two separate radicals. Now, right now I have square roots. I'm going to put n there as well because this applies to any kind of root, so cube root, fourth root. So when we say radicals in general, it doesn't matter if it's square root, cube root, fourth root, it works. And then the same idea for the quotient rule. If I have the nth root of A divided by the nth root of B separated, we can make this all under the radical, the square root of A over B. Okay, so let's look at some examples of how we would use this. So let's say first square root of x to the 8th y squared. Okay, so what I could do is I can look at this as the square root of x to the 8th and separately times square root of y squared. So then I can kind of look at these one at a time more so and think about what is the square root of x to the 8th. Well, that's x to the 4th. So if you remember, if it's like a 2 here, if we think of it as a rational exponent, we're doing 8 divided by 2. And the square root of y squared is just y. So it helps to kind of pull things apart. How about this one? Square root of 9 over 25. And this one, maybe you've seen this before without really thinking about this as a rule, but to make it a little easier to think about, I could change this to square root of 9 over square root of 25, and now just think, okay, square root of 9 on top is 3, square root of 25 on the bottom is 5. So maybe you've already even used this rule without realizing it. How about square root of y over 36? So here's one where we're going to use the quotient rule again, because I'm not going to be able to do both parts of these. I'm not going to be able to simplify, but if I break it apart to square root of y over square root of 36, I can do the square root of 36 on the bottom, which is 6. I can't do anything to the top, so that just stays square root of y. So it helps too if I can only do parts, simplify parts of my problem. Okay, how about this one? Square root of 2 times square root of 8. So now I'm going the other way. So the last three we just did, we started off with one radical, one square root, and then we pulled it apart. Now they're pulled apart, and we're going to look at how is this helpful if I can put them together. So I'm going the other way now. I'm now, instead of pulling it apart, starting with one radical, pulling it apart, I'm starting with 2, and I'm going to put them together. So because right now I can't do the square root of 2, I can't do the square root of 8 and get nice numbers, but if I put this as square root of 2 times 8 together, now under that radical, 2 times 8 is 16. Square root of 16, now I can simplify to get 4. So now it comes out to a nice perfect square. Okay, one more. Let's do a cube root one. So cube root of 54x to the 10th, and this is going to be all over the cube root of 2x to the 4th. Okay, now again, so kind of like the last one, it was two separate radicals being multiplied. Now I have two separate radicals being divided, cube root this time. So because these don't come out very easily, I can't simplify these very easily. Let's see what happens if I put them all under the cube root. So if I make this cube root of 54x to the 10th over 2x to the 4th, all in one radical. Okay, now I'm going to simplify because it looks like I can do 54 divided by 2, which is 27. And then x to the 10th divided by x to the 4th. So I'm using my quotient rule of exponents here. 10 minus 4 is x to the 6th. Okay, now I'm kind of looking at these separately. So I'm now using really the product rule, breaking these apart. I'm not going to rewrite it this time, and I'm just going to kind of be using the product rule, thinking about first, what is the cube root of 27? Okay, and 27 is 3 cubed. So the cube root of 3 cubed is going to be just be 3. And then I'll kind of write out this one. So how about this one? Let's think about this in terms of like a rational exponent. 6 divided by 3. This is going to be x. Oh, let's switch back to blue. X squared. So 3x squared is what that simplifies to.